what they achieved is singular. Never been done before. Just to put in perspective, 100,000 GPUs, that's, easily the fastest supercomputer on the planet. A supercomputer that you would build would take normally 3 years to plan.
Right.
And then they deliver the equipment, and it takes 1 year to get it all working.
Yes.
We're talking about 19 days.
This year the theme is scaling intelligence to AGI. And it's pretty mind-boggling that when we did this 2 years ago, we did it on the age of AI, and that was 2 months before ChatGPT.
To machine learning. And the amazing thing about machine learning is that machine learning can learn pretty fast, as it turns out. And so as we reformulated the way we distribute computing, we did a lot of parallelism of all kinds, right? So we revolutionized deep learning because of our domain-specific library called cuDNN. Without cuDNN, nobody talks about cuDNN because it's one layer underneath PyTorch and TensorFlow, and back in the old days, Caffe and Theano, and now Triton, and there's a whole bunch of different frameworks. And so that domain-specific library, cuDNN, a domain-specific library called Optics. We have a domain-specific library called cuQuantum, Rapids. The list of Ariel for industry-specific
algorithms that sit below that PyTorch layer that everybody's focused on.
Okay, and I think Sam was just telling me that they had just decommissioned the Volta infrastructure that they have at OpenAI recently, and so I think it's we leave behind this trail of install base. Just like all computing, install base matters, and what came out of it was NVLink.
Right.
NVLink, so that we could take these systems that are excellent for training. But when you're done with it, the inference performance is exceptional, and so you want to optimize for this time to first token.
Right.
What NVIDIA is trying to do is build a computing platform for this new world, this machine learning world, this generative AI world, this agentic AI world. We're trying to create, as you know, what's just so deeply profound is after 60 years of computing, we reinvented the entire computing stack. The way you write software from programming to machine learning, the way that you process software from CPUs to GPU, the way that the applications from software to artificial intelligence, right? And so software tools to artificial intelligence. So every aspect of the computing stack and the technology stack has been changed. Isn't that right? Once you decide to come onto our platform, the other decisions you could defer. You could always build your own ASIC later. Right. We're not against that. We're not offended by any of that. The first thing that we are doing is we are reinventing computing. Do we not? We just said that. The way that computing will be done in the future will be highly machine learned.
Yes.
Highly machine learned. Okay. Almost everything that we do, almost every single application, Word, Excel, PowerPoint, Photoshop, Premiere, AutoCAD. You give me your favorite application that was all hand engineered. I promise you, it will be highly machine learned in the future. Isn't that right? And so all these tools will be, and on top of that, you're going to have machines, agents that help you use them.
Right.
Okay. And so we know this for a fact at this point, right? Isn't that right? We've reinvented computing. We're not going back. The entire computing technology stack has been reinvented. Okay, let's just take $50 billion, put it into generative AI. Isn't that right? And so now your company just got better.
Right.
Now, how much of that 50 billion would you put in? Well, I would put in 100% of the 50 billion because I've already got 4 years of infrastructure behind me. In your inbox, you have all these little dots and these little faces. In the future, there's going to be little icons of AIs. Isn't that right? I'm going to be sending them, I'm no longer going to program computers with C++. I'm going to program AIs with prompting.
Right.
And whatever its definition.
Right.
I almost don't think it matters fully what the definition is, nor do I really believe that the timing matters.
Right.
The one thing that I know is that AI is going to have a roadmap of capabilities over time, and that roadmap of capabilities over time is going to be quite spectacular.
Right.
All you have to do is right now, as we speak, go talk to digital biologists, climate tech researchers, material researchers, physical sciences, astrophysicists, quantum chemists. You go ask video game designers, manufacturing engineers, roboticists. Pick your favorite, whatever industry you want to go pick. Right. And you go deep in there and you talk to the people that matter and you ask them, has AI revolutionized the way you work? Right. And you take those data points and you come back and you then get to ask yourself, how skeptical do you want to be? Yeah.
Right. Oh, and well, there are reports out there that you and Larry and Elon had dinner. They talked you out of 100,000 H100s. They went to Memphis and built a large coherent supercluster in a matter of months. You know.
So first, three points don't make a line. Okay. Yes, I had dinner with them. Causality is.
What do you think about their ability to stand up that supercluster? And there's talk out there that they want another 100,000 H200s, right, to expand the size of that supercluster. You know, first talk to us a little bit about X and their ambitions and what they've achieved, but also, are we already at the age of clusters of 200 and 300,000 GPUs?
The answer is yes. And then the first of all, acknowledgement of achievement where it's deserved. From the moment of concept to a data center that's ready for NVIDIA to have our gear there, to the moment that we powered it on, had it all hooked up, and it did its first training. Yeah. Okay. Correct. So that first part, just building a massive factory, liquid cooled, energized, permitted, in the short time that was done. I mean, that is like superhuman. Right. Yeah. And as far as I know, there's only one person in the world who could do that. Right. You know, I mean, Elon is singular in this understanding of engineering and construction and large systems and marshaling resources. Incredible. Yeah, it's unbelievable. And of course, then his engineering team is extraordinary. I mean, the software team's great, the networking team's great, the infrastructure team is great. You know, Elon understands this deeply. And from the moment that we decided to go, the planning with our engineering team, our networking team, our infrastructure computing team, the software team, all of the preparation in advance, then all of the infrastructure, all of the logistics and the amount of technology and equipment that came in on that day, NVIDIA's infrastructure and computing infrastructure and all that technology, to training, 19 days. You know what? You don't want.
Did anybody sleep? 24/7.
No question that nobody slept. But first of all, 19 days is incredible. Mm-hmm. But it's also kind of nice to just take a step back and just, do you know how many days 19 days is? It's just a couple of weeks. Yeah. Right. And the mountain of technology, if you were to see it, is unbelievable. All of the wiring and the networking and, you know, networking NVIDIA gear is very different than networking hyperscale data centers. Right. Okay. The number of wires that goes in one node, the back of a computer is all wires. And just getting this mountain of technology integrated and all the software, incredible. Right. Yeah. So I think what Elon and the X team did, and I'm really appreciative that he acknowledges the engineering work that we did with him and the planning work and all that stuff. But what they achieved is singular, never been done before. Just to put in perspective, 100,000 GPUs. That's, you know, easily the fastest supercomputer on the planet. That's one cluster. A supercomputer that you would build would take normally 3 years to plan. Right. And then they deliver the equipment, and it takes 1 year to get it all working. Yes. We're talking about 19 days.
Wow. But you answered that question by starting off saying, yes, 200 to 300,000 GPU clusters are here. Yeah. Right. Does that scale to 500,000? Does it scale to 1 million? And does the demand for your products depend on it scaling to millions?
That part, the last part is no. Of course, the thing to realize is that the scaling law used to be about pre-training. Now we've gone to multimodality. We've gone to synthetic data generation. Right. Post-training has now scaled up incredibly. The idea that a model, before it answers your answer, had already done internal inference 10,000 times is probably not unreasonable. And it's probably done tree search. It's probably done reinforcement learning on that. It's probably, it's probably done some simulation. It's surely done a lot of reflection.
So let's talk about Strawberry and 01. Yeah. I want to be respectful of your time. So
I got all the time in the world,
excellent.
Guys.
Well, you're very generous.
Let's acknowledge that.
Right.
AI has the potential to do incredible good. It has the potential to do harm. We have to build safe AI.
Yes.
Let's just make that foundational.
Yes.
Okay. The part that is overlooked is when companies become more productive using artificial intelligence, it is likely that it manifests itself into either better earnings or better growth or both.
Right.
We have direct evidence of it, either as isolated of a case as an individual researcher,
for sure,
who is able to, with AI, now explore science at such an extraordinary scale that is unimaginable, or that we're designing chips that are so incredible at such a high pace, and the chip complexities and the computer complexities we're building are going up exponentially while the company's employee base is not. The software that we're developing better and better and better, because we're using AI and supercomputers to help us